Welcome to homework.
Hello, in the question we have given that the figure shows a uniform beam of length L and mass M. So this beam has total mass of M and hangs horizontally and is attached to vertical wall. A block of mass M is suspended from a far end of this beam. So this is the block M. A support cable runs from wall to the outer edge of the beam. Both cables are negligible. So wall exerts a force Fw on left of the beam, for which of the following action the magnitude of the vertical component of Fw is smallest. So, so now over here, see this capital M, this block will produce an clockwise moment. So now I will represent it by small m because over here we have this beam mass as also capital M. So not to get confused. So it will be m g L but with a negative sign because it is producing a clockwise moment. Then I have this beam. So this beam is again producing a clockwise moment. So that is mgl by 2 because this at from center we are talking. So this distance will be L by 2 and then plus. Now this tension force is creating an clockwise moment. Sorry, anti-clockwise. So this will be T into D that is equal to 0. So I can take minus sign common and cancel. So it will be mgl plus mgl by 2 minus td is equal to 0. Now we will take the conditions with different conditions and then see what is going to happen. So now see the options. Now keeping the support cable and block as shown in the diagram. So if I keep this over here, so this is the equation I get, and from here if I calculate, so if I calculate from here, so this TD will be so MGL plus capital M, sorry, so this is capital MGL by 2 minus T into L sine of theta that is equal to 0. So if I calculate from T from here, I will get 0.5 mg plus small mg divided by sine of theta. Now coming to the option B. So what it is saying, see, moving the lower end of the support cable to the center and leaving the block over here only. So now we are taking this cable at center. So what will happen? I will get this equation mgl plus m is capital M g L by 2 minus T L by 2 sine of theta that is equal to 0. Now from here if we gonna calculate this, so T will turn out to be, so it will be 0.5, so half, so it will be 0.5 capital Mg plus Mg divided by 0.5 sine of theta. So see, T is more greater over here. Then moving forward, we have the option C, that is keeping the lower end of the support cable at the outer end and bringing the block at the center. Now we bring this block at the center. So then equation will become this small m g L by 2 plus capital M g L by 2 minus T L sine of theta that is equal to 0. So I can take TL on this side and I can cancel L from all the sides. So I will get T is equal to 0.5 mg plus capital Mg into 0.5 divided by sine of theta. And then finally we have moving both support cable and the block to the center of beam. So now in the last case, in the D, we have to move this cable and this thing to the center of beam. So we will get mg L by 2 plus capital Mg L by 2 as it is, and then minus T L by 2 sine of theta is equal to 0. So from every side this L by 2 will get cancelled and we will get T as equal to mg plus capital Mg divided by sine of theta. So the answer for this will be, now see where, so see what happens is, so in this case, see the tension is smallest, the this in this case the tension is smallest because here it is 0.5, 0.5. So this is the thing. Then so the magnitude of the vertical component so is not of Fw is smallest in the case C. So the answer will be for this, so over here the tension force is smaller. So this option C will be the correct one, that is keeping the lower end of support cable over at the outer end of beam and moving the block to the center of beam. I hope you find the solution useful. Thank you.